Good evening, everyone. My name is Mahi Tomar from third year, trimester ninth. Today, I'll be presenting my project StockWorks, Comparative Stock Analysis and Prediction Platforms. This project was developed to help users compare stocks using historical market data, financial metrics, risk indicators, and machine learning based forecasting. Investors often compare companies before making investment decisions. However, the information is mostly widely spread through multiple websites and financial platforms. So the objective of this project was to create one single platform where users can compare two stocks visually, analyze risk and return metrics, evaluate company fundamentals, study cash flow performances, and view machine learning based predictions. So this allows users to make informed decisions. Now, this project was made in collaboration with my other team partner, Ashwani Mishra, from third year, trimester 9 as well. In this project, I was responsible for data collection, exploratory data analysis, financial analysis, and backend development through API, fast API. So, I'll be explaining that. The technologies that I used for that are Python, Fast API, Pandas, Matplotlib, Finance Library, SkyPy, PyTorch, Jupyter Notebook, and VS Code. Yahoo Finance was used as the primary source of the collected data, market data, and Fast API was used to develop the backend Fast API, backend API, and PyTorch was used for the prediction model. Now, to give you an overview of the data set was collected using the Yahoo Finance API through the Finance library. For each stock, the data set contains close price, high price, low price, open price, and trading volume. And also, the data spans multiple years, so allowing both short-term analysis as well as long-term analysis. Also, before beginning the analysis, I checked data types, missing values, summary statistics, and dataset consistency to make sure that the data is clean and sufficient and suitable for further analysis. Now, before I begin the implementation details, let's give you a short demonstration of the final platform. Here, this is StockWorks, our platform. Here, you can see I have already compared Apple and Google. These are the ticker names for Apple and Google companies. Here, we can see this red one is Google, which performed better than Apple in the last year. Also, here you can see we have so many financial values calculation that an investor needs to check before investing in a company. We have volatile, that is the risk, and Sharpe ratio, value at risk, P ratio, dividend yield, so much. And also we have the fundamentals like the how is the growth, how is the profit margin in the company, and how is the cash flow in the company. We can see all of that, asset turnover. So the objective of this platform is to give users a complete view of a company performance from a single interface. Also, users can explore risk analysis and everything. So finance indicators such as this revenue growth, earning growth, profit margin, etc. are also available here. So finally, this platform provide future stock predictions using a machine learning model. So now I will explain how these features were implemented. So the first step is exploratory data analysis, which is here. I did it in Jupyter Notebook. So now the first step was to import Finance library and import the loading data. Next, I downloaded the stock data. For this case study, I used Pinterest and Reddit companies. I use the data from the last 5 years of these companies. Then I perform some statistical summaries using head, describe, and info. Also, I checked for some any missing values just to make sure the data is complete. The data inspection was done, and then we have the closing price for Pinterest and Reddit to see for the company. And then next we have the correlation. Correlation is the relation between two features to see how much they depend on each other or how much they are related. So as we can see that the Pinterest correlation value is in negatives minus 0.15, which indicates there is a very weak negative relationship between price and trading volume. So this means as volume increase, price tends to decrease slightly. Also, the extremely small p value indicates that this relationship is statistically significant and unlikely to have occurred by chance. Well, on the other hand, we can see Reddit correlation is very near to zero, which means there is almost no relationship. There is non-existent relationship between the volume and closing price. Here, also the high p-value shows that the relationship is statistically significant. Next up, I visualize the closing price. We can see the very clear difference in closing price for the graph for Pinterest and the graph for Reddit. Now, also, as to explain why there is this first difference, is because the IPO went live for Reddit in 2024, which has just been 2 years. Hence, IPO, hence this Reddit is performing in such largely fluctuations and higher volatility, which is expected from an eWare company. And this Pinterest, the IPO went live in 2019, so we can say that the company is mature and the stock is performing more maturely and is more stable through prices. Here, the both are compared together and we can clearly see the vast difference here. Lastly, I also calculated the daily returns. So the daily returns are the values that measure the percentage that is changed from one trading day to another, from today to the next. So now this complete EDA phase provided valuable insights that were later incorporated into the backend analytics system. Now let's go to the backend. Here we are, this is the backend architecture. Now first, as I've used Fast API. So what is Fast API? Sorry. Fast API serves as the bridge between the front-end dashboard and the stock analytics engine. And here, as we can see, the backend module is divided into four different modules, that is data loader, data pre-processing, main, and metrics. Now first, let's go to data loader, which is responsible for loading the data, downloading the stock information. This function here accepts the ticker symbol, the period, and interval. Also, another thing to note here is this line here. Now, what it does it, if any invalid ticker is entered, then the function raises an error like ticker not valid 404 found, right? And it prevents incorrect pre-processing. So this creates a reliable data layer. Now, also this function retrieves data directly from the Yahoo Finance. Next up, we have data pre-processing. Now, in this data pre-processing module, extract the close value, the close price value column from the stock that is just downloaded. Now, most financial calculations rely on the closing value. So, isolating this information early on will definitely help later in the pre-processing. So, this also improves the code reusability and the modularity. Next, let's go to the metrics module. Here we can see I imported the Y Finance library and also the math library. So this matrix module performs the analytical core of the project. So this matrix module contains so many functions that we have calculated here. We have daily return, and as you can see we have used the closing value here. That's why we need the close price value. Also, as you can see, daily returns is also one of the important values that we need for other financial calculation, as it's used in almost all of the functions. So we have different values here: daily returns, total returns, annual volatility, Sharpe ratio. Now, all these also we have the growth, revenue growth, profit margin. So the person can see how much they will profit in a time, in a particular time that they are investing. Next, we also have the cash flow growth. So we can calculate the. So here we can see we have all the types of function here, and these are also some explanations written. Now, all these values are very essential if you are investing or if you are interested in the stocks. Now, it will take too much time to if I explain each of the function as it's clearly written here. So let's go to the main. Fast API application. Now here, first thing you can see from Fast API, I have imported Fast API HTTP exception. This here HTTP exception is responsible for handling errors such as invalid stock tickers. I've also imported Finance library SYF, and also from data loader module I imported data loader function. The data processing module I imported the get close function to get the close value, and from metrics module I have imported all the functions because we'll be needing all the financial calculations here. Now the very next line, the app is called Fast API. What it does, it creates it analyzes the initializes the first step of the backend, and it creates the application, Fast API application. Next we have, I will look at, now this slash here is known as root. So this root creates a get endpoint at the root of the URL of the application. And this definitely root function, this function runs whenever the root is endpoint is accessed. So now these, whatever I have written till here are the compulsory. It's like you write them in whatever you, however you want to use Fast API, but these are almost used all the times. Next up, this all are pretty similar to what we have done in the metric function. As you can see, here it's creating a get endpoint of the daily returns, and then is a function get daily returns. Here I have taken the value of ticker, then it's loading the data of the ticker, and the default time period is 5 years. So then here I'm taking the close value, squeezing it to see if the series of multi-index in squeeze it just so it can get the correct output that we need. Then here the return. So now in the return, as you can see, the daily returns is the function that we wrote in the metrics module. So here it is importing the function, it is calling the function from metrics module. So as you can see, in the function that we have written in the metrics module are now being used here, and close value that we've already got. So all these endpoints are basically written in a similar way. You have total return, annual volatility. Annual volatility is a risk, how much risk you have. Then we have the Sharpe ratio. Then we have value at risk, like how much you can lose in a day. And the Sharpe ratio is the return over the lowest return over risk. So the better Sharpe ratio, the better investment. Next we have the beta, is in how much the stock is affected by the market changes. Here we taken the load data from us for a stock, then we calculated the market daily returns, etc. Here we have all, then we are calling the functions with these values, and here we are the returning this. Similarly, we have revenue growth, profit margin, P/E ratio, etc. Here, as you can see, if result in none is to be raised the next exception, that is code 404, EPS not available for this ticker. Now here, all the companies have different financial values, or that they disclose to the public. So sometimes some values are not accessible to the public or are not released by the company. So in that case, any of this happens, we have the we have the error handler here, which can say EPS not available for the company. So next up, here we have the ROE, earnings growth, operating cash flow. This is just calculating the cash flow. This is basically functioning the same as the metrics module, but just in the fast API endpoint. Right. Next up, here we have all. Now this endpoint. This endpoint is similar to all the other endpoints. The only difference is that all the other endpoints are returning a single value of the function, while this endpoint will return all the metrics together, all the values together of any stock that you want to that you write here. So here we created this list, and in the list, then here you can see the result annuality is stored in the annuality value. This is again the same thing. We are calling the functions from the metrics module. So here we can see all this result is storing all these values, all this financial calculation, and these are the fundamentals, all the growth, margin, profit, loss, and all that. Here are the valuation, the ratios, the cash flow, and the leverage and efficiency. And at the end, it return result. So it returns the list of all these outputs. So along with all the single outputs, we also have one that contains all the metrics together. Now that's all for my now that's all for my 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 collaboration in this project. Also, oh, one thing I forget. Now also for the testing and validation, after implementing backend function, I created a testing notebook just to text just to check and test all these functions if they are fine or not before integrating them into the API. And we can see the testing notebook here. As you can see, I used pins here again, the Pinterest ticker, and as you can see, I used the close, then daily return, then total return, annual value. I calculated everything before integrating them into API. So I independently tested each of the function first before implementing them. Now let's go back to the API. So now the resultant findings of this platform, as we can see, the final platform successfully integrates exploratory data analysis, financial analytics, fundamental analysis, risk assessment, cash flow analysis, and machine learning forecasting. So the platform enables users to compare these insights through a single unified interactive interface. In conclusion, StarkWorks provide a unified platform for stock comparison and analysis. Now, the project combined data science, financial analytics, backend engineering, and machine learning in a single application. Through this project, I gained practical experience, more experience in data collection, exploratory data analysis, and this was my first time for fast API development, so I learned something new. Then we have financial analytics, which was also new, so I had to learn and understand all the new financial terms and calculation. Then we have the machine learning integration. Thank you so much. That's all.